Hello everyone, welcome back to another exciting moment. Um, this time around, we are going to continue with our revision of the past question that is the just completed um, NECO exam chemistry practical. In the last video, I told you that we are going to do that in another time. So I think that is necessary that I should do that at this moment. So the exam normally comes with volumetric analysis and qualitative analysis. In this qualitative analysis, the students were provided with samples tagged X and Y. So in that X and Y, the question said that they should put a little portion of the sample S into a test tube and heat. Then they say that test for the gases um, that may involve that may involve gases that may involve so that may be involved. Now, what we do here in this case, when you heat the gas, when you heat the sample, because the sample S happen to be zinc triisocarbonate 4 or zinc triazo carbonate 4. So and the other one, the Y happen to be aluminium chloride. The Y happen to be aluminium chloride. So it said that on heating, you will get an odorless colorless gas turns blue litmus red and turns lime water milky. That turns lime water milky on testing. When you test for the gas that is coming out, it's colorless, odorless, and the turning litmus paper, blue litmus paper red, means that it's acidic gas, and turning lime water milky means that is what? Carbon 4 gas. Carbon 4 gas present. Carbon 4 gas present. Carbon 4 gas present. So here they say that heat the portion strongly. The portion we have here, we heat it strongly. On heating strongly, what you will observe is that there's the residue there will turn yellow. Turns yellow, and when you allow it to cool, it will then be what? White when cool. So what does this is what? Zinc. It means that zinc ion present. Zinc ion is present in that in the compound or the sample that we have. So the next one, we have the Y. The Y now say that dissolve Y in distilled water. We dissolve in distilled water and shake thoroughly, then divide the solution into two portions. So when you dissolve in water, when you add water there, you have a colorless a colorless solution, a colorless solution, colorless solution, meaning that is what is soluble. Soluble what? S is soluble. You can say that Y is what? Y is soluble. Y is soluble, and that means soluble ions. Soluble ions likely present. Soluble ions are likely to be present. That's why we have it to be this. Another thing that you should note here is that since it's colorless, it means that transition ions are absent. Transition ions like ion 3, ion 2, and copper, they are what? Absent. They are absent. That's what is indicating that all these ones are what? Absent. And since it's soluble, it can also mean that we have soluble ions like sodium ion, potassium ion, and ammonium ion. They are likely to be here because these are the known soluble. They are known to be soluble in all cases. That's as the case may be in any of the compound of sodium ion, potassium ion, and ammonium ion. They are all soluble. So in the first portion, because we have already divided into two portions according to the question here, it said that divide into two portions. After dividing into two portions, so the next thing we do here is we say that to the first portion add dilute sodium hydroxide in drops. So when you add sodium hydroxide in drop, you will notice what? White precipitate. White precipitate will be observed. That's white precipitate because we have white precipitate. We have three possible ions that can give us that. Okay. No, we have calcium ion that can give us white precipitate with sodium hydroxide. We also have zinc ion that can also give us that. We have another one, lead ions. We also have aluminum ions. That means they are likely to be present. So we have all these ions. All these ions, they are the ones that can give us white precipitate with sodium hydroxide. We have calcium ion, zinc ion, lead ion, and then we have also aluminum ion. So in essence we have the precipitate now soluble in excess. Since it's soluble in excess, it means that calcium ion is not present. Do you understand? It means that calcium ion is not present. And then, since it's soluble, we have zinc ion, lead ion, and then we have aluminum ion, likely present. Now, these are the possible ion that is present. Now, the last one we have here, okay, the third test here, we have we have said that to the second portion, add dilute ammonium solution in drops. Add dilute ammonium solution in drops. So if you add dilute ammonium solution in drops, it will not really it can only eliminate the zinc, because if zinc is not there, it will be soluble. If zinc is there, what we notice there is that the zinc will be soluble in excess, while the other one will remain. While the other one will remain. While this other one will remain. So in order to get it clearly, to really eliminate all the ions that may not be necessary here, what we do here, before we add this our second portion, we add dilute hydrochloric acid. When you add dilute hydrochloric acid, what you notice that there will be no reaction, no visible reaction. When you add visible reaction with dilute hydrochloric acid, meaning that lead absent. So the next one, then we can then add our ammonium solution. When you add our ammonium solution there, when you add our ammonium solution in drops, we have a white precipitate. White precipitate, meaning that zinc ion, aluminium ion likely present. So the next one we're going to do here is the fourth test here, where we'll add in excess. The test that where we'll add in excess. So adding in excess now, excess of ammonium solution. When we add excess, then the last one we have here is the fourth. That says then in excess. Then in excess we have white precipitates insoluble. That means this white precipitates will remain in the solution, in the mixture. It will remain in the mixture there. That means since it remains, it means that aluminium ion is what? Present. It means that aluminium ion is present. Note, lead and aluminium will give you the same white precipitate, which is insoluble in excess ammonium solution. So that is why it's important that you compare, you add dilute hydrochloric acid in order to know exactly if lead is there. Because without doing this, you end up having two ions, which means lead and aluminium. But we never have anything of such. You never have anything of such. That in fact, when you're doing this such analysis, when you see something like that, you know that there must always be one. You must be able to identify one of them. So the best thing you do is that you add that in order to eliminate. This is the area from the point where you have from that point where you have maybe the possible presence of lead, zinc, iron. That's the point you will start doing your elimination in order to get the exact iron that is present. Thank you so much, and I'll thank you for your time. And like I used to say, I would like you to share, like, and make comments. Thank you.